It's great, Higher Maths 2015 Paper 2 Question 1, quite a standard one this. We're given a triangle and we have to work out the altitude, the median and the point of intersection. So our points that were given in the question are -5 and 7, -1 and -5 and 13, 3. So altitude first, so it cuts the opposite side at right angles. So I need to use m1 times m2 equals -1. So for part A, the gradient of AB is equal to y2 minus y1 over x2 minus x1 minus. So that's minus 12 over 4, which is minus 3. Therefore, the gradient of the perpendicular is equal to a third because m1 times m2 equals -1. And you've got 2 marks already for getting the gradient and then the perpendicular gradient. And then using y minus b equals mx minus a. Our point is 13, 3. So we've got y minus 3 is a third of x minus 13. So 3y minus 3 is x minus 13. 3y minus 9 is x minus 13. And we want to make it look like x minus 3y. So taking the 13 over to this side, that gives 4 equals x minus 3y, or x minus 3y equals 4. Just making it look like it's asking in the question. Part B says, find the equation of the median from B. So median means we need to cut AC in half and then use the gradient formula to find the gradient. So our midpoint, this is the average of the x's, minus 5 plus 13 over 2, and the average of the y's, 7 plus 3 over 2. 13 minus 5 is 8, divided by 2 is 4, and then 7 plus 3 is 5, 10 divided by 2 is 5. So there's our midpoint. So if I call our midpoint, let's call that m. Then the gradient between m and b. B is -1, 5, -1, -5. So our gradient is equal to y2 minus y1 over x2 minus x1. So just call that x2, y2 and x1, y1. We get -5, -5 over -1, -4, -10 over -5 is equal to 2. So we get a gradient of 2, and we've got 2 marks so far for our midpoint and our gradient, and then just find the equation. So y plus 5 equals 2x plus 1, so y plus 5 is 2x plus 2, or y equals 2x minus 3, 2 take away 5, and then there's our final mark. Okay, part C, find the point of intersection between the altitude and the median. So we've got 2 equations. We've got x minus 3y equals 4, and we've got the other one we've just worked out. So let's note these down. X minus 3y equals 4, and y equals 2x minus 3. You can do this any way you want, but I'll just make them both look the same. So if I taking this one and putting it underneath, we've got y. We've got minus 2x plus y is equal to minus 3. And we've got 2 simultaneous equations we can solve. So times in this one by 2, we get 2x minus 6y equals 8. Minus 2x plus y is minus 3. Add because the signs are the same. Minus 6 plus 1 is minus 5. 8 plus minus 3 is minus 5. So minus 5y equals minus 5. Or y is equal to 1. So minus 5y equals 5. So y equals minus 1. There's our y coordinate, and then subbing it in. So we've got x minus 3y equals 4. So x minus 3 times minus 1 equals 4. X plus 3 equals 4, so x equals 1. So the point of intersection is just 1 minus 1, and we're done there. Okay, completing the square. SQA Higher Maths 2015, paper 2, question 2. The functions f of g are defined on suitable domains by these. First of all, it's a composite function question, but then there's a bit of completing the square at the end. So part A, f of g of x. Well, f of x is 10 plus x, so that's 10 plus g of x. So that's 10 plus 1 plus x, 3 minus x, plus 2. We need to tidy that up a little bit. So I'll expand the brackets. That's 10 plus 1 times 3 is 3, minus x plus 3x is plus 2x, minus x squared plus 2. So that equals 10 plus 3 is 13, plus 2 is 15. So it's 15 plus 2x minus x squared. Or you can write that minus x squared plus 2x plus 15. But I'll just leave it there. Part B, I've got f of g of x equals minus x squared plus 2x plus 15. So taking minus 1 out of the common factor of the first two terms, I get x squared minus 2x. I've still got plus 15 on the end. So that gives me minus 1 x minus 1 squared, half the middle term, and then take away minus 1 squared. I've still got plus 15. So that gives me minus 1 x minus 1 squared, take away 1, plus 15, which is minus x minus 1 squared. Minus 1 times minus 1 is 1, so 1 plus 15 is 16. And that's it in completed square form. C says another function h of x is 1 over f of g of x. What values of x cannot be in the domain of h? So part C, h of x is 1 over f of g of x, which we've just completed the square of, so it's 1 over minus x minus 1 squared plus 16, or otherwise, but the denominator cannot be 0. So we can just write that for the domain, for that to be valid, the denominator cannot be 0. So that implies minus x minus 1 squared So try to solve that equal to 0 to see what that gives me for it. When it is 0, I can then say x can't be these numbers. So we've already completed the square, so we can just say minus x minus 1 squared equals minus 16. Divided by minus 1 means x minus 1 squared equals 16. Square root on both sides, then you get x minus 1 equals 4 or minus 4. So that means x either equals 4 plus 1 is 5, or x equals minus 4 plus 1 is minus 3. That means x cannot equal 5, or x cannot equal minus 3, and we're done there. Basically, Higher Maths 2015, paper 2, question 3 had this long one. This is a version of the following first appeared in print in 16th century. Who cares? A frog and a toad foot at the bottom of a well is 50 foot deep. Each day the frog climbs 32 foot, rests overnight. During the night it slides 2/3 of its height above the floor of the well. The toad climbs 13 foot before resting, then it slides 1/4 of its height. So we need to see what this question is asking us, but it gives us two recurrence relationships. It says the progress can be modelled by this. F of n plus 1 is a third f of n plus 32, and the first term is 32. And then for the toad, Tn plus 1 is 3/4 Tn plus 13, with the first term is 13. And it says f and t are the heights reached by the frog and toad at the end of the nth day after falling in. Part A, calculate T2, the height of the toad at the end of the second day, only worth 1 mark. So to calculate T2, you just sub in T1. So let's just go ahead and do that. So for part A, t2 is going to equal 3/4 of t1 plus 13, but we know that t1 equals 13. So therefore, we can just say that t2 is equal to 3/4 times 13 plus 13. Nice and simple there. Well, this was a calculator question, so we just do 13 times 3 is 39, divide that by 4 and add 13, and we get 22.75. Okay, part B of the question says, determine whether or not either one will eventually escape the well. Now this seems to be like, well, what's this asking me? Whenever a question says, basically, will something happen after a certain amount of time and it's to do with recurrence relationships, it's asking whether it's got a limit or not, okay? So if you understand that when a sequence has a limit, you'll be fine. Now, a sequence has a limit when A, the number in front of here, f of n or t of n in this case, is between -1 and 1. So let's just save that. So for part B, if we look at our frog first of all, that is f of n plus 1 is a third f of n plus 32. Let's just write that down. We can say that a limit exists because -1 is less than a third is less than 1. So limit exists since -1 is less than a third, which is less than 1, and we can calculate that limit. So the limit, remember, is equal to b over 1 minus a, where that's my a and that's my b. So that equals 32 over 1 minus a third. And since it's a calculator question, you can just do that in a calculator, or without a calculator, that's 32 over 2/3. Now I'll just do it without a calculator just to show you how. So L would equal 32 times 3/2. Divide by a fraction times by its reciprocal. 32 divided by 2 is 16. 16 times 3 is 48. So the limit, or in other words, where the frog will reach, will be 48. Now 48, we know the well from the question is 50 feet, and therefore the frog will never reach or escape the well. So therefore the frog will never escape the well as 48 is less than 50. And then we can do the same thing for the toad. So let's look at our toad. His recurrence relationship was Tn plus 1 is 3/4, Tn plus 13. So the limit exists since -1 is less than 3/4, which is less than 1, and we can calculate that limit. L equals b over 1 minus a, which is 13 over 1 minus 3/4, which again, you can just use your calculator to work this out, but that is 13 over a quarter. 13 over a quarter is the same as 13 times 4 over 1, so that is 52. So we can then say the toad escapes the well since 52 is bigger than 50. And we're done there. Mr. Clare here from Clare Maths. Today we're going to be looking at a paper 2015, paper 2, question 4 of the SQA Higher Maths exam paper. Let's jump straight in. Okay, this one was about a wall plaque made to commemorate the 150th anniversary of the publication of Alice in Wonderland. Okay, so the edges of a wall plaque are modelled by quadratic functions, and there's 1, 2, 3, 4, and it gives you 4 bullet point equations. So what makes this one difficult is it'll give you all these equations, all this information, but you just need to keep your head. So let's look at part A. Find the coordinate of the point of intersection of the graphs of y equals f of x and y equals g of x. So point of intersection means simultaneous equations. So the two ones I need are this one and this one. Since that would equal y and y, so I can just make both of these equal to each other. So to get 1 mark for part A, I'll just do here, I can just write a quarter x squared minus a half x plus 3 equals a quarter x squared minus 3 over 2x plus 5. And that'll give you your first mark. Okay, now we need to solve that to get the x part. And it only asks for the x part, so that's good. Notice if you've got the same thing on both sides, they just automatically cancel. So immediately I can just get like a red pen or something and go, that's the same as that. Same sign and everything, so I can cancel them. I've got minus a half x, so I can add 3 halves x to both sides. And that will get rid of it on this side. So let's just do that and do it in stages. 3 halves take away 1 half is 2 halves, which is 1. So that just gives us x left on this side plus 3 equals 5. And then we can just solve that to find x. Take away 3, so x equals 2. As unlikely as it seems, our answer. Part B says the graphs of f of x and h of x intersect on the y-axis. The plaque has a vertical line of symmetry. Calculate the area of the wall pack. You should know a power word for integration is area. So if it says area, you need to integrate and you need to find the 2 limits. So we've already got our first limit at 0. We need to know this one. Well, this one is going to be the same as this one, which you worked out in part A, where these 2 intersect, was 2. So that's just 2. So I need to do the integral of the upper f of x minus the lower h of x between 0 and 2. So making sure you copy it down properly, it's the integral between 0 and 2 of f of x, which is a quarter x squared minus a half x plus 3. Put that in brackets. Take away h of x, which is this one, 3/8 of x squared minus 9/4 of x plus 3 dx. So at that point, you may be wondering, well, how much marks do I get? Well, at that point, you get a mark for knowing to integrate, so using the integration sign, just that. Another mark for putting in the limits 0 to 2, and then another mark for writing down the 2 curves taken away from each other. So 3 marks for literally doing no work. It's not bad, that. And then we need to integrate it, and you actually only get 1 further mark for the integration. So all the tidying up you're going to do now, you're not going to get any marks for, but you still need to do it to be able to integrate. So let's tidy this up. So that gives us the integral between 0 and 2. You've got a quarter x squared minus 3/8 x. So a quarter is 2/8. So being very careful, you've got 2/8 minus 3/8. You've got minus an 1/8 of x squared. Looking at the x parts, you've got minus a half minus minus becomes plus. So plus 9/4. Well, putting a half into quarters is 2/4. So you've got minus 2/4 plus 9/4 is 7/4. So plus 7/4 x. And then we've got our number parts, but they cancel. 3, take away 3 is nothing. So we get the integral of this between 0 and 2. And then we need to integrate it. So that gives us x cubed. Add 1 to the power and divide by the new power. So 3 times 8 I need to do, which is 24. And then plus x squared. I've got 7 still, but I need to divide by 2. So I've got 4 already on the bottom, so 4 times 2 is 8. And that's between 0 and 2. So that gives us another mark at that point. So let's move on and substitute our limits in. So we've got minus 2 cubed over 24 plus 7 times 2 squared over 8. Take away minus 0 cubed over 24 plus 7 times 0 squared over 8. Okay, so we get a mark for our substitution. And then we need to evaluate it to get another mark. So we could use a calculator at this point because it is a calculator paper, but I'll just go ahead and do it without. So we've got 2 2s are 4 times 2 is 8 over 24, so minus 8 over 24. And then the other number, 2 2s are 4, 4 7s is 28, so you get 28 over 8. And luckily, you've substituted 0 in here, so that is a big fat 0 for this. 0 cubed is 0 over that is still 0. 0 squared is 0, over that is still 0. So you just need to work out these fractions. So I can simplify the fractions. Well, actually, I'll add them first before I simplify because it'll be easier to see. So minus 8 over 24. And then we've got 28 over 8. 8 threes is 24. So times them by 3. I get 3 times 20. So we get 84. So now we can add them. 84 take away 8 is 76 over 24. Simplify that because you have to always have simplified answers. So I'll just divide through by 2 to get 35, 36, 37, 38 over 12. Divide them by 2 again to get 19 over 6. And 19 is a prime number, 6 doesn't go into it. So 19 over 6 is our final answer for another mark. And feel free to do that in any way you want to get 19 over 6. But that isn't the answer. You need to check your question. Calculate the area of a wall plaque. Well, we have calculated the area from here to here. So all that bit, if I was to draw a line down here, but you can see it's symmetrical. It even tells you it's symmetrical. So the area of the wall plaque is double the area I just found out. So our final area, just to get our final 7th mark, the area, total, equals 19 over 6 times 2. 2 times 19 over 6, well, that's the same as 19 over 3. So 19 over 3 is our final answer for our final last mark. This has been Clever Maths today. We've been looking at an integration question, quite a difficult one from 2015, paper 2. Take care, stay safe, and goodbye. X-Grade Higher Maths 2015, paper 2, question 5. Circle C1 has equation x squared plus y squared plus 6x plus 10y plus 9 equals 0. And the centre of C2 is 9, 11. There's C2 there, so let's just call that 9, 11. And the touch, determine the radius of C2. Well, we'll just find out all we can, so let's see if we can find the centre of C1. We have got this equation here, and we know from the start of the exam paper that minus g minus f is a circle's centre. So to get minus g minus f, you just divide these by 2 and change the sign. So that becomes 3, 5, so that's minus 3 minus 5. So we can write that for that centre. What else do we know? Well, we also know the radius of C1. So if we knew the radius of C1 and maybe this whole distance, we could find the radius of C2. So let's do the whole distance first. So the distance between, let's call it C1 and C2. Distance formula is Pythagoras, so it's 9 minus minus 3 squared, the x's, plus 11 minus minus 5 squared. That equals the square root of 12 squared plus 16 squared. That is 400, which gives me 20. So we now know the distance all the way up here is 20. So let's now find the radius of circle C1. So again, start of the exam paper, radius is equal to the square root of g squared plus f squared minus c. So we know g and f are just our centres. So therefore we can say the radius of C1 or R1 is equal to the square root of 3 squared is g plus 5 squared is f minus c, which is minus 9. So that is 9 plus 25 minus 9 is 25. So therefore the radius R1 is equal to 5 units. So we now know, I'll just use a different colour, that from here to here is 5. And therefore from there to there must be 15. Therefore R2 equals 20 minus 5, which is 15. And we're done there. So it now says, for part B, a third circle is C3 is drawn such that C1 and C2 touch internally with C3, and the centres of C1, C2, C3 are collinear, so they line up in a straight line. And we have to determine the equation of C3. A little sketch to illustrate this will be handy for you. This point here is minus 3 minus 5, and we know that the other point is 9, 11 here. And we want to know where the centre of the big circle is, and therefore what its radius is. So we're kind of looking at this line going through. Now we know the radius as well of C1 is 5, so we know that this line here is 10. We only got 5 on this side and 5 on that side. And we also know the radius of our big circle now is 15, or our big one in the middle. So that's 15 and 15. So we can use ratio to see how much the line divides the circles. So you should be able to see that a centre of the big circle, if I just kind of draw it there, is kind of roughly there. So if I kind of mark that point, that's the centre of like C3 roughly there. And we need to know where that is. So let's see how we divide this up. So if I kind of just draw a right angle triangle here, there it is. You can see that this distance is going from -3 all the way over to 9. So that's 12. And we can see that this distance is from -5 all the way up to 11. So that's 16. So the diameter of a big circle is 30 plus 10, which is 40. So the radius of a big circle is 20. So we know that from the big circle from here to there is 20. Or just like that, the radius of 3 is 20 at the side. So we know that this bit here is like 5. So this bit in here must be 10 because it goes 10 plus another 10 makes 20. So that must be 10 in there. So if we think about moving from here to here, we move 15 units. And then from here to here, we move 5 units. So the ratio is 3 to 1. So if we divide 12 by 4, we get this line must be 3. And if we divide 16 by 4, this line up here must be 4. That must be a 3, 4, 5 triangle there. So then we can get the centre just by working backwards from 9, 11. It's taking 9, 11. Our centre, which I'll just do in a different colour. 9 minus 3 is 6. And 11 minus 4, 7. So we get our centre of our circle finally is 6, 7. So we've got our centre and we've got our radius. So the equation is x minus 6 squared plus y minus 7 squared equals 20 squared. And we're done there. Or we can say x minus 6 squared plus y minus 7 squared equals 400. SQ Higher Maths 2015, paper 2, question 6. Vectors P, Q and R are represented on the diagram below. It's a parallelogram and ABE is an equilateral triangle. And it says the size of P is 3 and the angle ABC is 90. And we can see all that in the diagram. So let's jump in and see what it's actually asking us about this question. Evaluate P dot Q plus R. So we can just expand that to say part A, P dot Q plus R is equal to P dot Q plus P dot R. Now, start exam paper tells us that it's A dot B is size of A times the size of B times the cos of the angle in between. So we can see that that is size of P, size of Q, cos of the angle in between, plus the size of P times the size of R times the cos of the angle in between. So let's look at the size of P and the size of Q. Well, it says the size of P is 3. Let me just take a note of that, which means all of these are 3, obviously, because it's an equilateral triangle. So size of P and the size of Q, that's 3 times 3, times the cos of the angle in between those. Well, it's an equilateral triangle, so these are 60-degree angles. So we can write 60 degrees for each of them. So it's the cos of 60, plus the size of P again, which is 3 times the size of R, and then the angle in between, cos of, well, what's the angle in between P and R? Well, let's have a look. It goes along P, and then R is perpendicular to it, so that's a 90-degree angle. So it's the cos of 90. Well, that is handy. Perpendicular, the cos of 90 is equal to 0. So if two vectors are perpendicular to each other, then this A dot B equals 0 for them. So that's great. So now we've got the cos of 60 to work out with a non-calculator. So remember, we've got 60 degrees down here, 30 up here. If that was 2, this would be 1 and that would be root 3. So the cos of 60 is a half. So that equals 3 times a half, plus 3 times the size of R times 0. 3 3s are 9 times a half is 9 halves, plus nothing is nothing. So we get 9/2. Question B says express E to C in terms of P, Q and R. So let's go back to our diagram and see where E to C is. We want to go from here all the way over to here. Now, we can't go this way because I don't know what this is, so I'm going to go the other way. So I'm going to go E to A, that's minus Q, and then I'm going to go along here, that's plus P, and then straight up here, well, that's parallel to R, and it's the same size, so it is R. So we've got minus Q plus P plus R. So I just need to write that down. Part B, E to C equals minus Q plus P plus R. Little lines underneath these because they're vectors, but that's fine if you missed that. He says, given that A to E dot E to C is 9 root 3 minus 9/2, find the size of R. Well, where's A to E? So A to E is here. So let me just write this out first. We've got A to E dot E to C. Well, we know that A to E is Q dot, and E to C is what we just found out in part B, so we can just write that down, minus Q plus P plus R. And we can then just expand this and see what we get. So that equals minus Q dot Q plus Q dot P plus Q dot R. So then using our formula of Q dot Q is the size of Q times the size of Q times the cos of the angle in between, that gives us minus size Q cos, well the angle in between is a vector which is the same, well, but imagine my pen's a vector, there's no angle, so 0, cos is 0, plus the size of Q, size of P, and we actually already did that before, it's cos 60, plus the size of Q, size of R, and cos. We'll go back up to the diagram to try and find the angle in between Q and R. If I draw R here, say, and Q there, then you've got R and Q. And if you look at this diagram here, there's my Q there, and I've just moved my R there. You should be able to see that this angle here is 30, because 60 plus 30 is 90. So that's a 30-degree angle. So back down here, we've got the cos of 30. Okay, so what does that mean? So we've got the size of Q times the size of Q. The size of Q is 3, so that equals minus 3 times, and the cos of 0 is 1. Plus size of Q, size of P, 3 times the cos of 60, we know is a half already, plus the size of Q, which is 3, times the size of R, and the cos of 30 is root 3 over 2. But the question tells us that all of that equals 9 root 3 minus 9 over 2. So just keeping that in mind. So let's just try and tidy this up. We've got minus 3 times 3 is 9 times 1, so that's minus 9, plus 9 over 2, plus 3 root 3 over 2, times the size of R, equals 9 root 3 minus 9 over 2. So moving everything over to the right hand side, that means we've got 3 root 3 over 2 times R equals 9 root 3 minus 9 over 2, and then minus another 9 over 2 plus 9. So that means 3 root 3 over 2R equals, well, let's just have a look at that, minus 9 over 2 minus 9 over 2 is minus 18 over 2. 18 over 2 is 9, so that's just minus 9 plus 9, which is 0. So all that's gone. So we've just got 9 root 3. So now we can just times both sides by 2 to get the size of R times 3 root 3 equals 9 times 2 is 18 root 3. So the size of R is 18 root 3 divided by 3 root 3. So that means that The root 3's cancelled, leaving 18 divided by 3. 3 sixes is 18, so the size of R is 6, and we're done there. Integrating a trig function, which also ties in with the chain rule. So we've got SQA Higher Maths 2015, paper 2, question 7. Part A, find the integral of 3 cos 2x add 1. So we've got the integral of 3 cos 2x plus 1 dx. You don't need to give yourself a headache here. You check the start of the exam paper and it tells you if you integrate cos, you get sine. So I know what that's going to give me sine. So we've got 3 sine 2x. The 1 integrates to x, but we'll get there in a minute because you need to be careful here. This is not cos x, it's cos 2x, so the chain will apply, so you differentiate 2x to get 2, and you then divide by it. So it's divided by 2. And now I can integrate the 1, so it's plus x, and then I've got a plus c on the end. So just tidying that up a little bit, I could write that as 3 over 2 sine 2x plus x plus c. And we're done there. Part B says show that 3 cos 2x add 1 equals 4 cos squared x minus 2 sine squared x. So it's a trigonometric question. We have to use our cos 2x expansion from the start of the exam paper. So part B, 3 cos 2x plus 1. I'm going to try and make that look like the right hand side. So cos 2x, I'm going to expand to cos squared x minus sine squared x. And that's still plus 1. So that's 3 cos squared x minus 3 sine squared x plus 1. Let's see what we're trying to make it look like. Well, there's no actual 1 in the question, so we're going to change 1 in a funny way, because 1 is sine squared x plus cos squared x. So taking that 1 out, we get 3 cos squared x minus 3 sine squared x plus sine squared x plus cos squared x. 3 cos squared x plus cos squared x is 4 cos squared x, and minus 3 plus 1 is minus 2 sine squared x. And we should be done there. Okay, part C, integrate sine squared x minus 2 cos squared x dx. We're going to use our result that we've just found out, because that looks very similar to this result. So let's have a look at what this result was. It was 3 cos 2x add 1. So as an aside, 3 cos 2x plus 1 was equal to 4 cos squared x minus 2 sine squared x. If I divide this by 2 then, I would get 2 cos squared x minus sine squared x. So let's just do that to start with, just so you can see what's happening. Divide by 2 on both sides. We would get 3 over 2 cos 2x minus plus a half equals 2 cos squared x minus sine squared x. But this is the opposite signs on here. So if I then divide through by minus 1, or move everything to the left-hand side, I suppose. There's another way to think of it. Then you get minus 3 over 2 cos 2x minus a half equals minus cos squared x minus 2 cos squared x plus sine squared x, which is exactly what I'm trying to integrate. So if I can integrate my left-hand side. So my integral becomes the integral of minus 3 over 2 cos 2x minus a half dx. So that equals minus 3 over 2 cos goes to sine, so sine 2x. And you need to differentiate the 2x to get 2 and divide by 2. So I'm dividing the whole thing by 2. A half minus a half goes to minus a half x, and we've got plus c. Dividing a fraction by a number means I can just times the denominators. So we get minus 3 sine 2x over 4 minus a half of x plus c. And we're done there. 2015 paper 2 question 8 of SQA Higher Maths. This is a crocodile stock and play located 20 metres further upstream on the opposite side of a bank. Crocodiles travel at different speeds on land and water. The time taken for a crocodile to reach its prey is minimised if it swims to a particular point, p metres upstream on the other side of the river as shown. And then it gives you a formula for the time taken in tenths of a second, given by this. Remember, x is this horizontal distance here. Part A says calculate the time taken if the crocodile does not travel on land. It was the context of the question, I think, that made this one difficult, and people couldn't quite understand what's it asking me here. Well, if it's asking me basically this, if it doesn't travel on land, it is in the water. If it's in the water, it's just swimming straight upstream at 20 metres. So part 1 actually is just substituting x equals 20 into this formula. So part 1, t of 20 is 5 root 36 plus 20 squared plus 4 times 20 minus 20. Well, that's 0. So that's just 5 plus the square root of 36 plus 400. And that equals 5 times the square root of 436. And that is 100. And once you get your calculator out, you do square root of 436, times it by 5, and you get 104. And just remember your units, it's tenths of a second. So that's part 1 done. Now let's look at part 2. Calculate the time taken if a crocodile swims the shortest distance possible. Well, let's have a look at this picture again. Swims the shortest distance. Well, a straight line is going to be the shortest distance. So if he just jumps straight up here and then walks the rest of the way, he must be walking 20 metres. So that means that he spends no time in the water. Because remember, x is how far he swam basically upstream. So he's not swum anything upstream, he just went straight across and he's went 20 metres on land. So in this, in other words, x is 0. So for part 2, you just have to substitute t equals 0 in to the formula. So you get 5 times the root of 36 plus 0 squared plus 44, times 20 minus 0. 5 times 6 is 30, 4 20s is 80. That gives us 110 tenths of a second. Part B, although the context of the question was quite unusual, to say the least, between these two extremes there's one value which minimises the time taken. If you're a higher maths pupil, you should realise that the one minimise means we're doing optimisation. And that should be a big key red flag for you. Find this value of x and hence the minimum possible times. So step 1, I need to get it ready to differentiate. So if we look at our t of x, we can do the surds can come a power. So that's 36 plus x squared to the power of a half plus 80 minus 4x just by multiplying out the bracket. Now we can differentiate this using the chain rule for this part. T dash x is equal to 5 times a half, taking the power down, 36 plus x squared to the minus a half. And then we need to differentiate the 36 plus x squared because of the chain rule, so times 2x. And then we'll still have take away 4 on the end because that's 0 and that is differentiates to 4. Tidying that up, we get 5 over 2 times 2x. 36 plus x squared to the minus a half. Take away 4. 5 times 2 is 10. Divided by 2 is 5. So you've just got 5x for the first term. We could say that's over 36 plus x squared to the half minus 4, or that's 5x over the square root of 36 plus x squared, take away 4. Now we need to look at our station points because we're trying to minimise the time taken, so it's an optimisation question. So just remember, for stationary points occur when t dash x equals 0. So we've got our equation 5x over the square root of 36 plus x squared minus 4 equals 0. Okay, moving the 4 to the other side, we get 5x over the square root of 36 plus x squared equals 4. And then we can multiply through by the denominator. In other words, 5x equals 4 times the square root of 36 plus x squared. And we can square both sides to get 25x squared equals 16 times 36 plus x squared, because opposite of a square root is squaring. And we can work that out. 25x squared equals 576 plus 16x squared. Moving the x squared over to the other side, taking away 16, you get 9x squared is 576. So x squared is divided by 9, 64. So x equals 8 or x equals minus 8. But straight away, minus 8 is not valid because x has to be a positive number. X is greater than 0 or equal to. So x equals 8 is our number. So the minimum time taken occurs when x equals 8. There's no need for a nature table this one because we know it's going to be a minimum. So minimum time when x equals 8. So we can then substitute that back into our t of x. So remember that would give us t of 8 equals 5 times the square root of 36 plus 8 squared plus 4 times 20 minus 8. And if you were to work that out using a calculator, you would get 98 tenths of a second. SQA High Maths 2015, Paper 2, Question 9 for the addition and double angle formula. The winds of a turbine are turning at a steady rate. The height h of the tip of one of the blades above the ground at any time t seconds is given by the formula. Express 36 sine 1.5t minus 15 cos 1.5t in the form k sine 1.5t minus a. So we can write 36 sine 1.5t minus 15 cos of 1.5t equals, well, k sine 15t minus a. K sine 1.5t, minus a. So expanding the right hand side, that's going to equal k sine 1.5t cos a minus k sine a cos 1.5t. If we look at what's in front of sine 1.5t here, we get 36. So 36 equals what's in front of sine 1.5t on this side, k cos a. And similarly, looking at what's in front of cos 1.5t on this side is minus 15. And in front of cos 1.5t on this side is minus k sine a. To rewrite that more nicely then, I can say that k cos a equals 36 and k sine a equals 15. And now we're ready to get our k. Because sine squared plus cos squared equals 1, that means our k squared will be 36 squared plus 15 squared. So in other words, k is equal to the square root of 36 squared plus 15 squared, a bit like Pythagoras. So that is the square root of 1521. Use your calculator to verify that. And the square root of 1521 is 39. So we know that k is equal to 39. And also we can work out our a because sine divided by cos is tan. So since tan a is sine a over cos a, I can write tan a is equal to 15 over 36. So I can find the inverse tan of 15 over 36. Inverse tan of 15 over 36, making sure my calculator is in radians, is 0.395. And now I just need to check which quadrant our angle is in. So drawing a cast diagram would help with this. Now remember, we're going back and looking at what cos and sine were. Well, we're both positive. So cos was positive, so that's A and C, and sine is positive, so that's A and C. So I'm in the first quadrant, so that means that A equals 0.395. And therefore, to answer our question, we get 39 sine 1.5t minus 0.395. And we're done there. So to follow on this question, it then says, and hence find the two values which tip of blade is at a height of 100 metres above the ground during the first turn. So we've just expressed this in this form, but then you've got plus 65 on the end. So we can just write that again, plus 65, and that's going to equal 100. So I'll go ahead and do that. So that means, I'll just call this part 2, our h equals 39 sine 1.5t minus 0.395 plus 65, and that's going to equal 100. So we've just got an equation to solve now. That means I can take the 39 with 65 across, so we get 39 sine 1.5t minus 0.395 equals 35. So dividing through by 39, we get sine 1.5t minus 0.395 equals 35 over 39. So at this point, I can find the inverse sine of 35 over 39 using a calculator and get a value. The inverse sine of 35 over 39 is 1.114. And looking at our cast diagram, sine is positive, so it's in the first and second quadrants, so that's pi minus the answer. So we can also do pi minus 1.114 to get a second solution, and that is going to be 2.03. So that means we can say that the whole of this equals that, and the whole of this equals that, and solve for t. So 1.5t minus 0.395 equals 1.114, and 1.5t minus 0.395 equals 2.03. So solving the first equation, 1.5t adding 0.395, we get 1.509. And therefore t is 1.509 divided by 1.5, 1.006. There's our first solution. And our second solution, 1.5t equals 2.03 plus 0.395, which is 2.425. And therefore t dividing through by 1.5, 1.617. Just put my units in here, so that's seconds and that's seconds. And we're done there.